Here I go with a very quick description of the NANDA index and agent facts architecture and why you should care about it. So as we've discussed already, the NANDA index is a two-layer architecture for discoverability, handshake, and identifiability on the internet of AI agents. The first layer is what we call a lean NANDA index. This lean index uh, stores very static information that pertains to agentic entities on the agentic web. And a very important aspect of this lean index is that it follows a quilt-like architecture. What this means is that we can support a variety of different types of agents that have a variety of different types of governance, ownership, certification, and so on and so forth, right through this quilt-like architecture. So entities on this NANDA index could be directly registered or available via the index, like the first row over here, which could be my neighborhood bakery and its agent, but they could be government agents or government authorized agents, such as analogous to .com or .co.uk on the web today. Or they could be enterprise agents. For example, companies like Salesforce, Google, Microsoft, so on and so forth, could build their own agents, have their own registries for their own agents, certify them, authorize access to them, all that stuff. They own control to the agents. We just provide access to them via the registry through, think of it as a link from the NANDA index. Of course, there are other types of entities associated with Web3 based agentic registries or enterprise based agents that are directly registered on the NANDA index. But really, the idea is think of the NANDA index as the first handshake layer for agents that don't know each other or don't know of each other on the agentic web. If you're trying to find an agent that does a particular task, you would first look up using the information on the NANDA index and associated agent facts to find this agent and to find the agent's endpoint. Once you know who you want to talk to, you don't need to come back to the index ever again. It's a peer-to-peer communication. So the index is only for identifiability and the first handshake. So a typical entry inside the index record looks like this. It's intentionally and by design built to be extremely lean. So entries, fields in a particular agentic entry include aspects like the agent ID, the agent name, what we call the agent facts URL, which is a detailed, certified, cryptographically signed metadata schema for agents that I'll talk shortly, as well as aspects such as endpoints for the agent via routers, time to live, signatures, so on and so forth. So if you notice, all the aspects on the index record are largely static and not intended to change over time. This is by design because we expect a large number of agentic entities to exist out there on the agentic web. And if the index or registry records contain things that are dynamic, which I'll talk to you about shortly, then read-write cycles will scale up very rapidly and scalability will be affected. With that being said, and adding to that point, the second layer of the NANDA index architecture is what we call the agent facts metadata schema. The goal of the agent facts schema is to, the goal of the agent facts schema is to affirm agentic identity, advertise endpoints, show audited capabilities, as well as allow for aspects such as telemetry, certification, all of these things. So the agent fact schema is extremely detailed, but here is a largely complete description. The agent facts includes, as of today, aspects such as agentic identity, agent ownership, provider information, endpoints, including the ability to provide endpoints in the form of routers or load balancing, aspects such as agent capability, agent latency, skills, which can be audited by third party and cryptographically assigned, performance metrics, benchmarking, telemetry, and trust and verification, to include a few things. So the idea of, and for those of you who are well versed with what's happening in agentic AI and the agentic web. Some of you would think that this is similar to what is called agent card by Google, which they launched with A2A. And in philosophy, all of these are JSON-based metadata schemas to advertise agent capability. What is very critically different about agent facts is the ability to not just show self-declared capabilities and self-declared attributes, but also allow for critical aspects such as certification, auditing, verification, which we think is going to be extremely important on the agentic web when agents are intelligently transacting with each other without human oversight. Uh, One of the important aspects, which I alluded to before, that comes from the NANDA index being a quilt-like architecture is that it allows for various diverse types of agentic resolution paths. For example, an agent, as I said, could be a NANDA native agent, which means it's directly registered via the NANDA index, in which case the index entry would point to the agent facts URL for the agent, and then you would get the detailed metadata for the agent, which could of course change at any point of time. But because it is hosted in a decentralized manner, independent of the index, it is very scalable. A second type of resolution would be enterprise native agents, which means agents that are controlled and governed by enterprise entities. In which case, the NANDA index would simply be a redirect, or it will allow you to go to this enterprise registry via the access point that's defined by that particular entity, through which you would be guided to the agent facts URL for that agent, and rest all moves forward similarly. And the third type of agent are enterprise certified, enterprise governed, enterprise created agents, but those that are directly listed on the NANDA index as well to allow for searchability and aspects such as that. In which case, again, the resolution involves going to the NANDA index entry from which you are directed to the agent facts URL, and then from where you are directed to the endpoint for the agent with which you can then talk in a peer-to-peer manner. The one thing that you should take away about the NANDA index is that it's supposed to be, which is, as has been the theme of the day, a quilt-like registry or quilt-like index architecture, which means it's supposed to accommodate various different types of agentic entities that will exist out there on the agentic web. These will include MCP servers, A2A agents, Microsoft NL web agents, edge devices as agents, decentralized agents, some other types of agents that may exist out there in the future. But really the idea of NANDA index is to allow for interoperability and discoverability between all these different types of agents that are growing in silos today, and allow for them to orchestrate and interact with each other to truly make the agentic web decentralized and accessible to everyone. Obviously, it's not just about talking about these things. So the NANDA index today is publicly available. We have, if you go over there, you will be linked to our GitHub repo for the NANDA index, which also has a bunch of API functions where you can add your agentic entity to the index, you can update the entity, you can delete the entity, all of these things. And once your entities are on the NANDA index, you can use that. You can essentially host any types of agentic entities, and you can use those to build very cool applications that Maria and Aish will talk to you about shortly. Apart from the NANDA index, which is public, up and running, you can add your entities to the index yourself. We also have the agent fact schema and specification public on our Project NANDA GitHub. You can look at the specification. All of this is in open source. If you think you'd like to suggest some updates to your agent fact schema, you can make pull requests to the repo. If you think there are certain fields that need to be added to the schema, all of this is being developed out here in public along with all of you here. With that being said, hope that gave you a brief understanding of what the NANDA index is, why it's designed the way it's designed in this two-hop architecture for scalability and allowing for autonomous agents. And now I'll hand over to my colleague Maria, who will now talk to you about some of the cool applications that we've built here at Project NANDA on top of the NANDA index. Before that, as we are handing over, any questions? Yeah. So great question. You're talking about a, uh, a problem that is one level deeper, which is semantic search. So for example, if you want to search for agents that are of a particular type, like restaurant agents or legal agents or stuff like that, that is an application that we envision will be built on top of the index. Think of the index similar to DNS. You can't do Google search on DNS, right? But Google search uses DNS to allow you to search different things based on semantics. So the NANDA index is the foundational infrastructure that allows all agentic entities to be visible, discoverable on the Internet of Agents or the agentic web. And search applications, we are thinking about this here at Project Nanda, but I'm sure a lot of other people are also thinking about it. Built on top of the index will enable these types of things. But index is a critical component.
Yeah, I wanted to kind of answer that. I think there's always a trade-off between discovery and searchability, right? So you can either have a laundry list of everything, or you can live in the Google world where things are not easy to find. If you search on your own, if you try to, nothing is listed, so you have to go and somebody has to scrape and deliver. And we think in the agentic web world, as I said, there are less than 1 billion websites, so it kind of works out. But if you have trillions of agents, and especially the agents are in places where they can't attach themselves to a known entity, how do you discover them? So to make it more democratic, a highly centralized solution would be, there'll be a DNS of all the agents in the world. So even if there's an agent that's going to just, serve the scores of, today's Red Sox game, they would just come up, register themselves on a DNS-like, lookup table of 1 trillion agents and go away. That would be very cumbersome because updating that trillion-long lookup table would be very expensive because you'll have to keep copies of it at the different universities, as we saw earlier. So that would be impossible to keep up. The other solution would be to let somebody else find it, like you're saying. But then the problem is you have this incomplete discovery where an agent that's relatively unknown will never be discovered as such. So this becomes a more democratic approach where the somewhat static index is accessible to anybody, and then they can go and find what else is to them. So I want to make sure that people understand this massive difference in how we can make it more democratic. And a lot of our colleagues here from various companies, John is right here, he's been challenging me on this from the beginning. And another thing John mentioned was this notion of being able to support, he's from Akama, of course, but being able to support CDNs. So what does it mean in simple words? Like if you have an agent running here and somebody in Indonesia wants to use the same agent, are we going to serve it from here or somewhere else? What does it mean? So you're kind of constantly create these agents and their copies, and you might have one DNS entry for them, but they might have different agent facts and so on. So all these things have to be thought through to create a very nimble experience.
I have this question. Sorry.
Go ahead.
Yeah.
Is this scalable? Because, think of having 1 trillion agents. How may I find the one I want? So, instead of looking for some category or something like that?
Yeah. So it's a great question. So as the number of agents increases with time, what would be the criterion for search, right? So of course, there will develop technologies such as category-based search or reputation-based search mechanisms, trust-based search mechanisms, all of which will build on top of the index as all of this scales. So of course, you would not just go to the index to search all the agents, like a teaching agent or something like that. But you need the index as a source of truth for all the agents that exist out there, all the agent metadata that exists out there, to build these scalable search algorithms on top of that will allow for searchability on this internet of trillion agents. Yeah, it's very similar to how Google search works, right? Like there are so many web pages today that likely do the same thing, right? But Google has this thing called page rank. So when you search something on Google, it'll give you like an ordered list of top 50. So maybe search for agents will also have something like this in the future. Of course, this doesn't exist today, but I'm sure something like this will show up.
So wouldn't the domain registry then
it'll be federated, of course. But yeah, but that's also why it is lean, right? As opposed to it being detailed. When you have so many agents, it really, what's the more difficult aspect of maintaining such a large registry is the read-write cycles that scale with n as the number of agents increase, as opposed to just the number of entries you have on the list. So one of the reasons we made it lean is that okay, you obviously need to record as many agents as exist out there, but because it's lean, you don't have that many read-write cycles on the registry, but on a decentralized set of agent facts. Yeah.
How many federated replicas will actually have? How will things get cascaded between them?
There will be companies that will maintain thousands or even millions of agents of their own. They might have only one agent.
Yeah. So it's like top-level domains versus agents as subdomains of the top-level domain. So I'm sure there'll be various such models that come out as we scale up. But in a sense, yeah, every top-level domain analog would have an entry on the index, and agents could be linked within that. Yeah. Sorry, could you repeat the question? Yes. Yeah. Yeah. So you're saying time to live for entries on the, yeah. So if you saw the index entry, that's actually one of the fields on the index entry, which is the time to live for the entry. So absolutely correct. There'll be different types of agents that will exist out there. Some will be ephemeral, which means they come and go very fast. Some will be persistent, which means they stay for a while. And so absolutely, the index entry as well as the agent facts, in fact, will have time to live aspects, after which they'll not be trusted anymore and they need to be relooked up. Yeah. So valid question. We have not thought about imposing some cost of being on the index as such, but what could be a incentive to not spam with faulty entries or erroneous entries on the index would be the reputation systems that will build on top of the index. Mm-hmm. Yeah. Yeah. So for reputation system mechanisms, right? Absolutely. So the attack surface changes as the entities change, as agent entities come up. So there's obviously an active research direction that people will figure out to ensure that these reputation systems are robust enough. Just for the sake of time, we'll continue with the session, and I'll be happy to take questions offline. Thank you so much.